Alright, good morning. I've been playing with the bucking and half bucking, repelling, and different configurations, and I have something very interesting using what I found in the last video about the bucking increasing the amperage. I'm trying to find a magical formula to amplify that. Okay, so I got this going. So I'm not going to go over all the wiring right now, exactly what it's doing, but I'm just going to show what it's doing. So coming out of the 12-volt battery, goes right into here. This is the only wire feeding the whole circuit. You have, what is it? Let me get my other glasses on. 150, 120. In between, barely anything, like 100 milliamps, 150 milliamps, somewhere about there. Okay, that's what's coming out. Then going back into the battery, we got 816 milliamps. Okay, so out of this 100 or 200, real small amount coming out, I got 800 milliamps going back in. Now it's still a loss because I'm taking 100 milliamps out of the battery, but it'll last like forever. But in exchange, I have 1 amp, 0.2 plus 0.8 going through this wire. 0.2, well, 1 amp going out and 0.8 coming back. So like 1.8 amps going through if you add both ways for the cost of 100 milliamps. Now what this is gonna mean, not sure yet, working on the next step or still poking around, but look at that. That's cool. Now I could start using higher frequencies as you're hearing it hum, because we're repelling and we're taking away resistance, or changing the impedance to a lower impedance when you buck. But this is actually a mix of buck attract, buck attract, buck attract, because I'm using the back EMF to buck against the forward with it rectified, so the back EMF is always one polarity and the switching is both polarities bucking against each other. And when that happens, you get this, barely any input. Input's almost in a dungeon, it's almost at zero, and you get steady 800 milliamps output. So we're gonna see if we could keep working with this.